So I'm going to talk today about a new way in which you can do motion capture under clothing. And this is work done primarily at the University of British Columbia in collaboration with Vital Mechanics Research, which is a spin-off from UBC. We built soft avatars, and we got, for example, data for the soft avatars in the lab using 3D body scanners, also a lot of motion capture to look at how things move. A sensor probe that we developed to track the body movement as well as the probe so that you can cancel out the relative motion. But the challenge throughout has been, how do you actually measure the motion without getting people to take off all their clothes? Or we have a solution for this, and I'm going to describe it in two parts. One, which is the general idea that you can use electromagnetic sensing to deal with all the occlusion problems. Track motion under clothing. And previously, we used just the position of the electromagnetic sensors. So that's what I mean by 3DoF, or 3 degrees of freedom. These sensors are actually capable of measuring directly 6 degrees of freedom, not just position, but also orientation. The idea is that we attach these electromagnetic sensor units, we call them EMUs, to the skin directly. So now you know that it's actually tracking the position of the skin. In terms of precision, they actually do pretty well. The bigger problem is accuracy. So the absolute accuracy can be very poor. So when you go to about a meter, the accuracy of these sensors drops to about 10 centimeters. Now that's why people haven't been using EM sensing before. You can improve that accuracy by calibration, by being able to measure ahead of time with some ground truth and to fix those accuracy problems. We can take care of that by calibration. So we learn a neural deformation field, which is basically predicting, given a position, what would be the correction at that particular point. So this is looking at 3 degrees of freedom. You can see in red, the original had at about a meter, it had 10 centimeter type of an error. Whereas with this calibration, well below centimeter, 10 times better than the raw data. So they're like a motion capture suit, which many people hope is actually capturing body motion. So we have sensors under the suit, but as you can see, there's significant slip between optical and electromagnetic. So the motion capture suit is giving you a lot of error because you're actually measuring the clothing. We can also, for example, you can measure motion under clothing like we can also do that inside a 3D body scanner, so you can get geometry at the same time. And you can also do multi-layer garments. You can have here, for example, you can see how the skin is moving relative to a sweater that you're wearing, and maybe you're wearing a windbreaker on top of that, so you can track all these layers of clothing because about the 6dof part. The process is exactly the same. Now we need to capture like the motion of a coordinate frame. So we've extended the EMob electromagnetic sensing system to 6dof. You can now capture both position and orientation on the skin with just one tiny sensor that you can attach to your skin. It's not perfect, by the way. Just the big limitation is wires and also the need for and the limited range, because there are, I think, many cases where there is no other way, and particularly I'm quite interested in looking at slip, how clothing slips on the body. And we can also do this now inside a 3D body scanner. For people who've been using motion capture suits to get to do motion capture, maybe a little bit of a reality check that you are not actually measuring what the body is doing.